Welcome back, and we're working on 10.2, and now we're going to show how we can use Laplace transforms to solve systems of linear differential equations. We're going to focus on those with constant coefficients, and we'll take this system of differential equations, x prime equals 3x minus 2y, y prime equals negative x plus 4y, where x of 0 is 1, and y of 0 is negative 6. Again, our Laplace transform on x of t is capital X of s. Laplace transform on x prime of t will be s capital X of s minus x of 0. So s capital X of s minus 1. Laplace transform on y of t is y of s. And Laplace transform on y prime of t will be s times y of s minus a negative 6, so that will be a plus 6. So if we take a look at our differential equation, x, and we do the Laplace transform on him, x prime is s x of s minus 1 equals 3 x of s minus 2 y of s. And y prime is s y of s plus 6 equals negative x of s plus 4 y of s. So now we've converted, using the Laplace transform, our system of differential equations into a system of linear equations without derivatives. So let's solve one of these for one of the variables and then use that to substitute in for the other one. I'm going to go ahead and choose x of s. So if I move this to the other side and these guys over here, I'll get x of s equals negative s y of s plus, oh, that'll be a minus 6 plus 4y of s. Okay. Or I might want to write that as y of s times, how about 4 minus s, and then a minus 6. Okay. Now, let's remember that that's all of x of s. So we'll put that in place of x of s in the other equation. So s times x of s, which is the quantity, y of s times 4 minus s minus 6 minus 1 equals 3 times x of s, which we've solved for as, again, y of s times 4 minus s minus 6 minus 2 y of s. And now we have a single equation in one unknown, namely y of s. Let's see if we can distribute through and then solve for that y of s. So a couple of algebra steps here, we're going to get 4s y of s minus s squared y of s minus 6s minus 1 equals 12y of s minus 3s y of s minus 18 minus 2y of s. Okay, let's see if we can collect all the y of s terms together. So let's subtract 12y of s, add 3s y of s, and add 2y of s. So we're going to subtract 12y of s, and we're going to add 3s y of s, and add 2 y of s while we're at it. Okay. And while we're still here, let's see if we can do this all at once. Plus 6s plus 1 plus 6s plus 1. So let's see what happens when all the dust settles. So we'll have a negative s squared y of s. Okay. So with the sy of s's, so we'll have 3sy of s plus, or sorry, 4sy of s. So that's plus 7s y of s. And then we're going to have negative 10 plus 2 is, or sorry, negative 12 plus 2 is negative 10 y of s equals, we've got negative 18 plus 1 is negative 17. And then we have plus 6s. So let's see what we get here. Let's times everything by a negative 1 and then factor out the y of s. So we've got y of s times by s squared minus 7s plus 10 equals 17 minus 6s. So y of s would equal negative 6s plus 17 over s squared minus 7s plus 10. That's actually going to factor, so let's see if we can do that. So that'll be s minus 5 and s minus 2. So we're going to need some partial fractions to break this guy down. So let's write that as a over s minus 5 plus b over s minus 2. And when we do that, we're going to get some negative 6s plus 17 equals a times s minus 2 plus b times s minus 5. Setting s equals 5, we're going to have negative 30 plus 17 is 13 is equal to a times 3. So a should equal 13 thirds. And if we set s equal to 2, that's negative 12 plus 17 is 5 is equal to 0. Let's see, s, so 2 minus 5 is negative 3. So negative 3b. So b should equal negative 5 thirds. Therefore, y of s equals 13 thirds. Let me slide this up now. Of times 1 over s minus 5 minus 5 thirds times 1 over s minus 2. And to get y of t, we do the inverse Laplace transform on this guy. Okay. And that will give me 13 thirds. The inverse Laplace transform of 1 over s to the, or sorry, 1 over s minus 5 is e to the 5t minus 5 thirds e to the 2t. Now we found out what y of t is. Okay. We can then go back and find x of t. And several ways we can do that. So I'm going to pause the video and let you do that.